Howdy. This is the ESET 462 final project called MOP.
Michael Lee.
I'm Jeff Weisling.
I'm Jake Marshall.
I'm Adrian Favela.
This is the link to our folder for Google Drive. And once we have this video link prepared, we will update this slide with the links to that, as well as the robot working and the color sensors working. This is the description of our project, focusing on the controller plant and feedback. The color sensor will act as the feedback. Our plan is to have it detect what color it is on the track, and based off what color it is detecting from the track, either go directly forward, go slightly to the left, slightly to the right, so that it stays in the middle of the track. The DC motors are going to be used to make the robot go forward. It will adjust the speed of each motor depending on what we want it to do. And the microcontroller is an Arduino that will be taking in the data from the color sensor, and that is how it will be updating the DC motors on what to do. Uh, this is a rough figure showing what it will look like. As mentioned earlier, the controller will be feeding into the motors, telling it what to do. The sensor will be telling it, will be detecting what it is, hence why it's going back to the color sensor error, and then back to the controller. Once it sees what color it is on, once again, feeds back into the loop, controller will update the motor on what to do, and it will repeat the process at a high frequency so that it's constantly checking what color it is and what it needs to do.
So here next is our distribution of work that we allotted for our project. And obviously we have 4 members, so we have kind of 4 different, I guess, chunks of our work. So Michael will be focusing more on the code for the color sensor detection. He will also be kind of being the main person to develop the kind of PID settings and optimizing that side of things. And then Adrian will be assembling the chassis, the motor, the sensors, and the wheels. And with that, he'll be working on the motor control implementation. I myself, Jeff, will help with developing the PID to maintain this course and also the code for the motor control. And then lastly, Jake will be creating the track that we will actually be following, and then also implementing these connections and the communications that the DC motors and the color sensor and the Arduino are communicating back and forth with each other.
So this was our original plan of execution. Originally, we had 1 day set aside for hardware assembly. So that meant putting together the chassis, the battery, the Arduino, the motors, all of that, as well as installing the color sensor, its wires, and then testing that all the parts were working properly once they were all connected with each other. We originally set aside 2 weeks for code development. So that was writing code for the color sensor values, as well as implementing basic motor control, and then developing code to get error value based on the different colors that the sensor was receiving, as well as implementing the PID terms. And then lastly, whatever leftover time we had just to test and calibrate the overall project robot, testing with open loop, testing with poor PID gains, and then tuning the PID to better execute as it went through the track. This was our actual execution of the project. So we actually had to spend a week on hardware assembly. This is because while we were assembling the chassis, we encountered some issues with the motor, and it took a little bit longer for us to actually assemble the entire robot rather than how we expected it to be. Our code development did actually take the allotted 2 weeks. We just happened to while assembling the hardware, we bridged off and also worked on the code. We also decided that rather than using 2 to 3 different color sensors, we would go with one. So that way we could detect 3 different colors along the track with a single sensor. And the code was developed for color recognition as well as for the motors to function based on what color was being detected by the one sensor. Lastly, we had 1 week for test and calibration for the robot. When testing the first day, we were almost successful, but not all the way because we had a couple of issues with the color sensor. We met up after Thanksgiving, and Our testing was very brief, but we were able to execute and finish the project.
Now, this shows the planned project timeline that we had. And as Adrian was mentioning, we originally had this hardware assembly as only 1 day. And then our code is a big chunk of our time, and same as the testing. And then as we see in the actual project timeline, again, as Adrian was saying, the hardware took a lot longer. But the code still took about the same amount of time, a little bit less from that. And then testing was again shortened as well.
So this is our PID code for the robot. We only use PD. The I was for integral, which was this test if the robot was constantly drifting or not, but luckily it wasn't, so we set KI as 0. We use proportional for the immediate correction. So the larger the error in this case is the deviation from the color red, meaning if it sees more blue or more green, it was either the track was changing directions, and either the robot was drifting to the right or to the left, it would correct and try to recenter itself. Derivative is for how the change in the error. So if it was correcting itself too fast, like if it was turning left, but it was approaching red too fast, it might now go into the blue. So we wanted to adjust that. And these changes are for the motors. So the motors changing on the base of the error in the color. Expected project outcomes, robot will finish tape tracks at fast speeds while going off the tape. Successful PID tuning and color sensors give precise and accurate error feedback. The actual projected outcomes, we met all expectations. The robot did finish the track at relatively fast speeds. We had a successful PID tuning, and color sensors were giving us good error feedback.